Hello everyone, and welcome to Lab 8. In this week's lab, we'll be learning some basics of image processing. Image processing is to robots as the optic nerve is to humans. Image processing is a means for robots to see their surroundings and make decisions based on their location in space. Most practical applications involve real-time video processing. Many colleges that focus on mechatronics dedicate entire semesters to this subject. But because we are limited to a week, and most of you are either new to MATLAB or image processing, we will concentrate on basic tools in analyzing static images. In this case, we will program MATLAB to read a static image and count the number of objects in that image. In your class resources, you should find the image hexbugs.jpg. Open your MATLAB program and upload the hexbugs image into MATLAB. Now we will use the image read function so that MATLAB can see the image. We'll also go ahead and assign a variable to represent the hexbugs image. Let's type I equals imRead, hexbugs.jpg. When you press enter, MATLAB will open a new viewing screen with the image. Now every time we reference the variable I in our program, MATLAB will know we are referring to hexbugs. So how does MATLAB or computers in general understand images? Every digital image is read by a computer as a matrix of pixels. You could also think of a digital image as a grid with thousands of tiny squares, and each square is called a pixel. For color images like hexbugs, each pixel has a red layer, a green layer, and a blue layer. Let's inspect how our image is broken down into pixels. Here we will use the image tool function. Type imTool. A new MATLAB window should open with the hexbugs image and a toolbar at the top. Click the Inspect Pixel Values button on the toolbar. A small secondary window should pop up and a tiny viewfinder should appear on your hexbugs image. The small secondary window has a lot of squares with R, G, and B values in each square. If you move the viewfinder on your image, you will see the squares changing in the window. The viewfinder acts as a magnifying glass so you can see each individual pixel. The R value in each square stands for red, the G value stands for green, and the B value for blue. The values will range between 0 and 255. 0 is the lowest intensity and 255 is the highest intensity. If you move your viewfinder over a blue hexbug, you will find that the B intensity value in a given pixel will be closer to 255 than the other colors. If you move your viewfinder over the white background, the red, green, and blue values in the pixels will be approximately 255. If you move your viewfinder over a black area, like a shadow, all the intensity values will be closer to 0. The logic behind this is a basic color theory. Red, green, and blue are the three primary colors in light color theory. And because they are additive colors, combining red, green, and blue at different intensities will produce other colors. For example, if you combine red light with green light at equal intensities, you'll produce yellow light. That's why if you hover the viewfinder over a yellow area, the red and green intensities are high, and the blue intensity is nearly 0. If red, green, and blue are all present at high intensities, you will produce white light. True black, on the other hand, is the absence of all color, and all intensities are 0. You should be able to locate the MATLAB file lab8counting.m in your class resources. This file features basic image processing tools. To understand these tools, you must read the comments and unlock side missions within the code. Simply running the code without studying it will not help you in this lab. To complete this lab, you will be asked to upload a new image into MATLAB and alter the code so that MATLAB can accurately count the number of objects in that image. This concludes Mechatronics Lab 8.